Hello. Hi, everybody. Let's see. Let me make this work. Hello, world. It's Suraj. Hi, guys. Good to see you. Let me mute myself. Okay, there we go. All right. We've got people coming in the room. Hi, everybody. Hi, Preston. Hi, Shrey, Leandro, Ivan, Nico, Vishal, Nishant, Sebastian. All right. Got to kill it with that fresh TensorFlow. Shubhadeep, it is MNIST this time, but I will get fresher stuff later. All right, so okay, in this live stream, we are going to create a classifier in TensorFlow for MNIST. Okay, what does that mean? We're going to create a classifier in TensorFlow, no TF-learn, just TensorFlow, straight up TensorFlow, and we're going to do this for handwritten character digits, like images. So we're going to give it an image of like the number 6, and our model is going to be able to look at that and say, oh, this is a 6. So it's going to be able to read the image, the number that is in the image. And we're going to do this in straight up TensorFlow, all right? So that's what we're going to do, and we're going to start off with 5 minutes of Q&A, and then I'll get right into the code, all right? So 5 minutes starts now. That's a cool map, right? Yeah, I love that map because it's really colorful. Okay. OpenAI Universe. That is a question. Did Google contact you? They did, actually. I'm meeting them next week. We'll see what happens. I mean, I'm sure there's something we could do together. This is my apartment. Yep. How to study chemistry? Watch chemistry videos on YouTube. That's not my. I'm not into. Why are you so awesome? I just believe in myself. How does this differ from the example in the docs? I mean, this is kind of like a custom version. How many layers will your model have? It's going to have 4 layers. It's going to be a convolutional neural network with 4 layers. What is the dopest way to build AI to detect fake articles on the internet? That's actually a hard problem that we are working on right now. Detecting if something is fake or not, like a validity test, is actually like, I mean, what does that even look like? Like if you had a set of articles that were labeled as real and a set that were labeled as false, I mean as fake, you could do it that way. But even then, like if a fake article was good enough, like it would just pass. So we need a very 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 strong, robust model for that, and like Google auto reply level amount of data that it's trained on. Will you use LSTM? Yes, I will. MacBook or Windows PC? MacBook. Will Scala be Python? No. Did you lift your job? Why? I used to work at Twilio, but I want to do this full time. Why don't you make a video about NLP, in particular the entity type recognition problem? I have several videos on NLP. I'm going to make more, though. What is your laptop specs? I just got the new MacBook. got lost in the neural network. Okay, so let's go ahead and do this. You guys can see me, right? No, I'm still here. Just someone say if they can see me. I just had a problem for a second. All right, let's see. I'm still broadcasting. Okay, I'm still broadcasting. Audio is back. No, they can't see me. Okay, hold on. Hold on. Camera off. Camera on. All right, there we go. All right. Okay, there we go. We're code. And so now you guys can see me. Okay, here we go. Okay, so we've got people watching, and we're going to screen share, okay? So screen sharing time. Share, okay? Boom. All right, so here we go. And all right, you guys can see everything dropped out for a bit. I'm gonna make this bigger. Okay, so now we've got 161 people watching, and this will, okay, so here we go. You guys can see, all right, beautiful, right, all right. So let's do this. So we're gonna import our first library, which is the future library. Why? Future is going to let us, so future is going to let us, there's lag, right? Okay, is there still lag? Man, I'm gonna get a better connection next time. I'm lagging. Okay, hold on. Hold on. Damn it. PS. Too much lag. Audio is good. Okay, bad video quality. Hold on. Okay, so it's still lagging. Okay, so the video is lagging. I'm not sure, and too much lag. Okay, so there's too much lag, and video lags a lot. Okay, so just try to restart it. Okay. Let's see. Restart. I can restart. Restart the what actually? So there's a little. I'm not sure. Okay. How about 123? Okay, so 123. So everybody, it's lagging, right? That's what's happening right now. It's lagging. That's what's happening right now. The stream is lagging. All right, so I'm just gonna keep going because I can't help but the lag. So I'm just gonna keep on going, and it's still lagging. Okay. Sound is okay, but the video is lagging. It's breaking. I'm just going to keep going. I don't give a. Okay, so for future, we're going to import the print function. Okay. All right, great. We're going to import the print function, and we're going to import TensorFlow. Those are our two libraries that we're going to import. And future is going to so that we can have the print function from Python 2, and we could do it for Python 3. Okay. So there's that. And so now we're going to. So we had that. Now we're going to import our data set. Okay. It's fine. All right. No lag. Close your browser tabs. All right. Good call. Actually, let me close that. Boom. 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 So okay. So we're going to import our data set, right? So the first thing we're going to do is we're going to import our example data set of the MNIST, and I'm going to talk about what format we're gonna import this as. Okay, so we're gonna import. This is our helper class, input data, and what input data is going to do is it's going to pull our data from the web, our MNIST, our handwritten character digits, our images. It's going to pull that from the web, and it's going to store it in our folder, and it's going to format it. format it so that we can use it in our code. Okay, so good. Finally, there's no lag. All right, and I'm sorry about the lag, guys. I'm going to not have this ever happen again. All right, so I'm going to work it out of a place where there is no lag. So we're going to create a variable called MNIST using our input data helper class, and we're going to use the read datasets method. We're going to read it from wherever it's saved. So it's going to save it to the temp folder, our data folder in our temp folder, and we're going to say one hot equals true. What does one hot equals true mean? That means that let's talk about this for a second. What is one hot encoding? Okay, so this shows up a lot. One hot encoding. One hot encoding is a way of formatting data, of representing data so that it's more machine readable. So what would be an example? So if I had an array like car, if I encoded this normally, I could just say like I could represent this as 1, 0, 2, 1. Okay, that's what I could say that. But what is this? This looks like tooth is the greatest value. Like it looks like tooth is greater than 1 because the value that I'm representing it as is greater. But this is wrong. Like the tooth isn't actually greater. I just need a way to differentiate between different data, right? So a better way of representing these would be as binary digits, so that I could represent house as 1, 0, 0, 0, and then I could represent car as 0, 1, 0, 0, and then I could represent tooth as you know what I'm saying. So there are different ways of representing of representing data, and it's using this kind of binary format. So it's a way that lets us encode data so it's more machine readable, and it's good for regression and classification. But no, it doesn't say that one is greater than the other. So that's what we call it. That's what we say one hot. Okay, it's a way of encoding it, but there's not like it's not greater than the other. Okay, so that's one hot vectors. Okay, so that's us getting our data set, import data. All right, so next step is to get the love you too, Michael. Next step is to get the hyperparameters. All right, so hyperparameters. These are our tuning knobs, and I'm going to talk about each of them. So, okay, so the first one I'm going to import is called the learning rate. Let me explain what I'm doing with here. So why am I setting it to 0.001? Okay, so as data flows through our neural network, we're going to apply an activation function at each layer. So what this function is going to do is it's going to transform our data in some way, and we're later going to use that transformed data to update the weighted connections between the layers. And so what the learning rate does is it's what we apply to that weight updating process. So the greater the learning rate, the faster our network trains. But the lower the learning rate, the more accurate our neural network trains. Okay, so it's that trade-off between time, like speed, and accuracy. Speed and accuracy. And one hot is used in word representations as well. And that's what all hyperparameters are. They're kind of trade-off between speed and accuracy. So that's our learning rate. And now we're going to have our training iterations. So how much do we want to train? And so we're going to say 200,000 iterations. Okay, so generally the more iterations, the better it's going to. The more iterations, the better our model is going to train. Okay, so that's for our training iterations. Now we want our hi Eva. Hey guys, say hi to Eva. She's my friend IRL. So for batch size, we want to say batch size is going to be 128. What does that mean? That means we have 128 samples. That's the size of our batch. The batch is what we train. Okay, all right. So there's that. And we're going to set our display step to 10. What does that mean? Well, how often do we want to display what's happening while we're training? Let's say every 10 iterations. So that's what we're going to say. We're going to say every 10 iterations. Okay, so there's that. And now we want to create our network parameters. All right, so for network parameters, we want to say how many, what is the size of our image? Let's say 784. What does that mean? I keep doing this minus sign. Let's say 784. So that means our image shape is going to be a 28 by 28 image, right? A 28 pixel by 28 pixel image. That's the size of our image. So there's that, and then our number of classes is going to be 10. What does that mean? Well, we have 10 digits, right? The digits 0 through 9. There are 10 digits. Now we're going to, our last network parameter is called dropout. Oh, I cannot wait to explain dropout. I love dropout, okay? Okay, here we go. Dropout, okay, is this awesome thing. So dropout is a technique created by Hinton. Landon, I'm gonna do another Q&A at the end of this session. All right. So what dropout is this awesome method invented by Jeffrey Hinton and his team that prevents overfitting by randomly turning off some neurons during training, so data is forced to find new paths between the layers to allow for a more generalized model. Okay, so what does that mean? So I think the best analogy I could think of is like old people. Okay, so generally they say like the older you get, the more set in your ways you are, and there's a kind of scientific truth to this, because there are these neural pathways in our brain, kind of like grooves that we kind of carve into our brain that we kind of get used to thinking about, right? And so that's kind of what it is with dropout. If you train your neural network a certain way and you don't use dropout, then those pathways are going to continually be the same way. So it's going to be too trained on the data. It's going to be too fit on the data you've trained it on. It's not going to be able to generalize well. It's not going to be able to predict new data sets. But what you could do with dropout is, while you're training, what dropout does is it randomly turns off neurons while the data is flowing through, right? While the data is flowing through, it's randomly turning off neurons, randomly. And so that the data is forced to find new pathways. And what this does is it creates a more generalized model. So the model is then able to train and test on all sorts of data. Okay, and dropout is a very, very successful technique. Okay, so that's what dropout is. That was a little bit long, but that's what we're going to use for dropout. And it's a probability. It's a probability value. Okay, and like everything else, it's a trade-off, and it's all about tuning. It's about trying and testing what works best. Okay, so that's that. Okay, so now we're going to create our placeholders. How we're going to get the data in there. So what we're going to say is, everybody say hi to Brian. He's also my friend IRL. So we're going to take our placeholder variable, our TensorFlow placeholder variable, and we're going to say none and then the number of inputs. What does this mean? This is our gateway. This is our gateway. Dropout is not like shrooms. Kind of it is, actually. It is. That's a great point. So we're gonna create. Let me just type this out, and then I'm gonna explain what is happening. What is happening today? Okay, so none, and then the number of classes. What is this? Well, we've created two gateways. We've created two gateways for our data. One gateway is for the images. The other gateway are for the labels. So we're gonna have an image like an image of the number 0, and then the actual label 0. And so both of those are going to be fed in at the same time. So our convolutional network is seeing our labels and it's seeing our images at the same time. Okay. Well, now we need one more thing. It's called key probability, which is going. And so TensorFlow's placeholder object is what represents those gateways. It's a gateway into our computation graph. So that's how the data flows into our computation graph. So we have our placeholders. Okay, so we need one more placeholder, and that's going to be a float 32. So it's a 32-bit float, and that's what our dropout. That's how our dropout is going to flow into our network. So we have three gateways actually. One is for our image, one is for our label, and then one is for our dropout. Okay. So there's that. And now what we want to do is create our convolutional layers. So let's create our convolutional layers, and I'm going to explain what's happening here. And so what we're going to do is I'm going to create a function for this. So it's going to be a 2D convolutional layer. It's going to take a set of 4 parameters. Okay, what are these parameters that I'm importing here? So what we're going to do is we're going to have these 4 parameters, and we're going to define our convolutional layer here. So I'm going to type this out, and TensorFlow has a built-in convolutional function, right? And so we're going to say, what are our parameters for this? Well, we already imported them in the main method that we just called here, and we have something called strides that I'm going to explain in a second. But strides takes in these strides that I've defined previously, 1, 1, 1, 1, and then padding is going to equal same, and then. Right, and so then x is. So let me explain this, okay? So look, this is why I have it into its own function. Because there's actually three things I want to do here. I want to do three. Here I go. I'm about to explain this. So what's happening here? Okay, so here's what's happening. Okay. Okay. So a convolution is so when we're feeding these images into our network, a convolution is basically taking that image and transforming it in some way. So that's what convolutional layers do. They take the image and they process it and they transform it in some way. So each layer is going to have some representation of that image, and it's going to get hierarchically more abstract the higher you go in your network. So the first layer is going to be a 2D layer, right? And we're going to add our bias to it. And what does a bias do? It's like all other hyperparameters. A bias it's a tuning knob. It's going to, I can make it go one way or the other, but generally what bias does is it makes our model more accurate, okay? And so there's that. And so what is convolution is a fancy word for transform, okay, for image transforms. And we're going to return the ReLU function. ReLU is an activation function. Rectified linear unit is the full name of it. But basically, it is an activation function, and we're gonna use it in our convolutional layer. Okay, so that's what's happening here. And then strides are the it's a list of integers, and it's going to be a tensor, right? So strides are our tensors, and tensors just means those just mean data. Tensors equal data, all right? So that's one convolutional layer, okay? I've created that as a function. Okay, thank you, Eva. Okay, so that's our convolutional layer. And so now I want to create another function called the max pooling layer. All right, so the max pooling layer is, what is pooling? Well, let me talk about what pooling is. We've created our convolutional layer, but let's talk about pooling, because this happens all the time in convolutional nets. It's like, Prakar, that's a great explanation. Convolution is like putting filters on an image. It's an increasingly abstract set of filters. Okay, so what pooling is a pooling layer takes small rectangular blocks, okay, from the convolutional layer, and it subsamples them to produce a single output from that block. So it's taking samples of an image. It's taking little samples, pools, okay, like little pools from an image, okay? And so they're going to be max pooling, because we want to take the average or the maximum of the learned linear combination of the neurons in the block, okay? So that's what max pooling is. So we're just gonna do one thing. We're gonna return the max pooling function. So TensorFlow has a built-in max pooling function, and that's what we're gonna return. Okay. So it's going to be the size 1k k1. So that is a 4D tensor. That's a 4D tensor. Okay. So there are 4 variables there, and the same thing about our strides. That's gonna be another 4D tensor. 1k k1, and padding is going to equal same. I'm going too fast. I will slow down. All right. So that is our pooling layer. And so now let's create our model. Okay, we've created our definitions here. Now let's create our model. Okay, so create model. And so we're going to say convolutional net x weights biases. So let me type out these parameters, and what's going to happen here is our model. We're going to take our x, which is our input, our weights, which are the connections or synapses between our layers, our biases that's going to affect each of our layers in some way, and then our dropout. Okay. So first, before we do anything, we want to reshape our input data. We want to reshape our input data so it is formatted for our computation graph that we're about to create. Okay. My screen share went off. Video is down for you. Hold on. What just happened? Hold on. Here we go. Turn camera off. Turn camera on. All right. Back. Video is back. Great. Video is back. Man, we are on an adventure today. Okay. Video is back, right, guys? Okay. So I'm going to say, I want to reshape my input. Okay, great. And This is the one time I'm going to have video issues, guys. I'm just recording out of my place today. I usually record out of my studio, but it's closed today. But I'm never going to let this happen again, all right? And thank you all for showing up to this live stream. I do this for you guys. I'm going to keep on doing it, all right? So, where were we? Right, so we're gonna reshape our input data, right? And what is the shape that we want it to be? Well, we can define that as our parameter here. We can define what our shape is going to be. And we want our shape to be it's going to be 28, what was our image? It was 28 by 28 pixels. And then our width and height we have here is set to 1, right? So that's how we're gonna reshape our input. Now we can call our convolutional layer. So now we're going to create our convolutional layer. And what is it? So we defined our convolutional function up there, right? So now we're going to actually use it. And guess what? We haven't actually defined our weights yet. I'm going to define our weights in a second. Right now, we're defining this function without defining our weight. So now we can set our biases. And our biases are going to be, what are our biases going to be? We haven't defined those either. So we're just gonna use these as placeholder first, and we're going to let's see. So that's our convolutional layer. That's our biases and weights. So now we have our max pooling layer. All right. So we've created our convolutional layer, and now we're going to add to that convolution max pooling. So then our max pooling layer is going to take that convolution that we just had. So it's going to take that maxpool 2D function that we just created. It's going to add another set of weights, and then we're going to have our biases as it's going to be DC2. Boom, boom, boom. All right. So that's our convolutional layer and our max pooling layer. Okay. And so what happened here? So we have our convolutional layer and our max pooling layer. So now that's our first layer. That's our first layer. And now we're going to do our next layer. Okay, so our next layer is going to be convolutional 2D, right? So that was our one of our layers, and now we're going to create our next layer, and it's going to take our previous layer that we just created as an input, and we're going to say weights are going to be WC2, and then, so again, we're going to define our weights in a second. We haven't really defined all of them, but we're going to define them in a second. And that's going to be our list of weights. And one more thing, we need to max pool this layer too, right? We want to max pool each of our layers. All right, so let me do that. Max pool 2D, convolutional 2D, k equals 2. And then, okay, so that's what we got. So that's our max pooling layers. All right, so now we have our layers, and now we want to create a fully connected layer. Okay, so we've got both of our convolutional layers, and now we can create a fully connected layer. Why do we create a fully connected layer? A fully connected layer is just a generic layer. That means like all of the layers are connected to every neuron in the fully connected layer is connected to every neuron in the previous layer. So the previous layers are 2 convolutional layers. So the convolutional layers are creating convolutions or transformations or filters of the image, right? And then a fully connected layer isn't. It's just representing that image, the image data. It's just a representation of image data without it transforming it in a convolutional way. So the first thing we want to do is we want to reshape it, right? We want to reshape the data for our convolutional layer, and then we want to get the shape, and it's going to be as a list. It's going to be as a list of inputs. And so, okay, so that is our first connected layer. And so now I am doing the next one. Okay, so the next one is going to be, we're going to add, so this is where the actual matrix multiplication happens. Okay, we're gonna take, this is where the actual matrix multiplication happens. This is where so Prakar said this is where the actual classification happens. This is where the matrix multiply happens. So all that data that we've been transforming, this is where we kind of combine it together. Okay, so what we're going to do is we're going to perform matrix multiplication using TensorFlow. So TensorFlow has a built-in matrix multiplication function. And for our weights, we want to use the same weights that we had. And then we're gonna use our biases as well. Okay, so we're gonna use our weights and we're gonna use our biases. Right, so there's that. And now, okay, now that we've done that, we're going to apply dropout. Okay, we've created our convolutional layers, our fully connected layers, and now we can apply dropout. Oh, you know what? Guess what? I forgot something. I forgot to add our activation function. What is our activation function? It is relu, and we're going to apply it to that layer. Okay, so now we're going to apply dropout. So we're going to take. So guess what? TensorFlow has a built-in dropout function, and we defined dropout earlier. Okay. Line 45, check the parameters. Let's see, convolutional 1, weights, and biases B2. Yeah, that works, right? So there's that. And so now we're going to say for our output, line 45. What's going on line 45? Line 45, we have max pooling, convolutional 1, max pool 2D. What is happening over here? Trying to figure this out. I thought line 46. Max pool 2D. All right, anyway. Line 40 is missing brackets. Oh, there it is. Okay, great. Thank you. Okay, cool. Okay, so anyway, so we applied dropout, and now we're going to have our output. And so what is our output going to do? Output is going to predict our class. So output is going to predict our class. Okay? So we're going to say, so now that we're at the very for matrix multiplication on everything that we've calculated beforehand. Everything that we've calculated beforehand. And so we're going to say our weights, it's going to be out, and then our biases. Are going to be out, and now we're going to return out. Line 47, convolution 2. Thank you. Thank you, Peppa. I appreciate that. Biases out, and then we return out. Okay, and that's it. And whatever we're returning here, that is our classification. Okay, that is our classification. All right. And hold on. Matrix multiplication. Hold on. 47. So 47 convolutional 2D. Yeah, what's happening on 47? Okay. 47 is convolutional 2D. Yes. Right. Okay, so now we return out. Convolution on, what are they saying here? TF.reshape. Convolution 2D convolutions. All right, so anyway, I'm just going to keep going here. So now let's create our weights. Let's create our weights. Yeah, let me make my editor a little wider. I'm not going to be able to see the comments fully. Okay, anyway, so let's create our weights. Weights are going to be, so we're going to create these weights as a dictionary, right? It's time for us to create our weights. And so our weights are going to be a list of 4 TensorFlow variables. Okay, so our weights are going to be a list of 4 TensorFlow variables. And we're going to say tf variable, tf.random. Yeah, I can use TensorBoard. Why don't I use TensorBoard for this? Okay, I'll use TensorBoard when I'm done. Right, and so okay, so it's gonna be kind of hard for me to write this out and explain at the same time. So what I'm gonna do is I'm going to just say, I'm gonna write this out and then I'm gonna explain what these weights are. So these are a list of values. And so what is this? So we're gonna say our variable is a tf.random normal. So it's gonna be the same kind of thing, right? We're just gonna have 4 TensorFlow variables, and each of these variables is, oh man, okay. Each of these variables is going to be a different value. Okay, and so it's going to be 64. So there's that, and then WD1 tf.variable. So here I go. I'm about to finish writing these. I'm on my third of 4, and tf.random normal 7 times 7 times 64 124. What am I doing here? So that's not an actual 1024. One more variable, guys. No. One more variable. Don't worry about it. One more variable, and we're good to go. All right. So tf.variable, tf.random normal. Right. It's the same thing. All of our weights we want, and then we're gonna say, and I'm gonna explain what's happening here in a second. Okay. Okay. So here's what's happening. Okay. Here's what's happening. We have our first set of weights. It's a 5 by, so here's our first set of weights. This is a 5 by 5 convolution with 1 input and 32 outputs. So it's a 5 by 5, that's at width and height, and then of our input, and then there's going to be 1 input, that's going to be an image, and 32 outputs. That's the bit. That's the number of bits. Another one, 5 by 5, 32 inputs, 64 outputs. What does 32 mean? There's 32 different connections. It's going 32 different ways, and 64, right? So it's taking one image and it's splitting it, and it's like splitting it like increasingly through our network. These are synaptic connections, okay? And so then it's going to be our fully connected layer. That's a way for our fully connected layer. 7 by 7 by 64 inputs, 1,024 outputs, okay? Lastly, it's going to take 1024 inputs at the last layer, and then this is where we actually predict our class. The number of classes is going to be 10. So those are our weights, okay? Now, let's go ahead and construct our model. Okay, so let's construct our model. Construct model. And let me know if it's laggy or not. Like, let me know if it's not laggy, because, okay, so I would appreciate that. So let's construct our model. Well, guess what? We already defined our Anthony Johnson, that was a thug life moment right there. Thanks for saying that. I should go a little slower though, yeah. The weights are massive, aren't they? The weights are massive. So now we're going to construct our model. What are we going to construct it with? We're going to construct it with our input data, X, our weights, that what we just defined, our biases, and our key prob, which is our dropout. Okay, so that's what we're constructing our model now. Now let's define our optimizer and our loss. And once we do that, we can start training. So what is our loss? We could call it loss, or we could call it cost. Let's call it cost. We're going to use TensorFlow's reduce mean function, which is kind of synonymous with reducing the loss. Okay, and what is the type of loss function that we want to use? Well, TensorFlow's neural network class has a loss function that is good for image classification called softmax cross entropy with logits. Okay, and let me explain what the F this is. Okay, this is a big fancy word right here, a big fancy mathematical word. So what is this doing? This is measuring the probability error in a classification task. Okay, it's measuring the probability error in a classification task. And it's when the classes are mutually exclusive. So that means that an image that is a 0 and an image that are 1 are exclusive. Okay? So that's our loss or cost. Let me just call it cost for simplicity. And now let's define our optimizer. What is our optimizer, and why do we even need an optimizer? Well, whenever we are creating a neural network, we want to create an optimizer. And we're going to use an optimizer called Atom. And what Atom does is it reduces the loss over time through a gradient descent process. A gradient descent process. Okay, I'm using the latest version of TensorFlow. And what is our learning rate? Well, it's going to take our learning rate as a parameter, which we already defined. Okay, and what is it going to do? Well, it's going to, and guess what? There's a function for this, minimize our cost. That's what an optimizer does. It minimizes our cost. And the the more we minimize our cost, the more accurate our model gets. And why are we using the Atom optimizer? Atom has become really popular recently. There are other types of optimizers we can use, like Attograd, okay? But for this case, we want to set. I'm going to use TensorFlow to visualize these weights at the end, yes. So now that we've created our optimizer and our cost, now we can evaluate our model. So what does this look like? So for model evaluation, we want to say, well, what is our correct prediction? What does that look like? We want to make sure our correct prediction, we want to see, okay, so I'm going a little too fast. Let me calm down. Everybody take a deep breath with me. Ready? A deep, laggy breath with me. Okay. We're calm. Everybody, it's all good. It's all good. Okay, so now what are we doing? We are evaluating a model, and we're using TensorFlow's equal function we are going to use TensorFlow's equal function to get the difference between the predicted value and what the test data is. So we have test data, and then we have our predicted value, and we want to see the difference between that. Okay, so that's what we're doing here. And accuracy. What is our accuracy? Our accuracy is going to be the difference between our correct prediction and whatever we predict. And so we're going to tf.cast the correct prediction, and that value is going to be a float 32. Okay, so now we can initialize our variables. So let's initialize our TensorFlow variable. And guess what? We always want to do this in TensorFlow. We always want to, no video, hold on. Oh, there's no video, hold on. Let me fix that. Boom, boom. There we go, video is back. Okay, so we're getting through this, guys. We're getting through this. We're almost there. Now we're ready to train our graph, and we're good to go. So we're going to initialize the variables, and the variables are going to be, so what are we doing here? Every time we initialize our TensorFlow graph, we want to initialize our variables. Okay? Every time we want to do that. So now we've initialized our variables, we can launch the graph. The graph is our neural network, but in TensorFlow we call it the computation graph. Okay, so so how do we do that? Well, we create a TensorFlow session, and a graph is encapsulated by a session. Okay, and so we're going to say run the session, and we're going to initialize the session. Okay, and we're going to say equals 1, and so we're going to keep training until we reach max iterations. All right, so let's go ahead and do that. So while the step, so now in this while loop, we're going to take the batch size, and we're going to say it's less than the training iterations. Let's see, what's happening here? We're gonna run our optimization, and we're going to feed it the values from our batch and our both of our batches and what's our last thing? Our dropout. Okay, so and our dropout. All right. Okay, so there's that, and then we want to print out what's happening here. I want to print out the iteration step and iteration step. Okay, so hold on. So now it's just going to be a bunch of print statements, and man, it is really laggy this time, and I'm like, okay, so anyway. Okay, so we have that. We have our model. So, all right, so let's see what this looks like. So Python, hold on. Let me maximize this. So what's happening here? Python demo.py. Right, so this is what it looks like. I'm gonna have to close that quote in the end. Okay, so I'm not going to train it right now, so that's going to add more lag because that's computation. But what it's doing is going to train on our label data set, and it's going to test on the label on the data set we have as testing data. And let me show you guys what I mean by hold on, by MNIST browser visualization. I have a little browser. If you want, here's what it looks like. Hold on. God damn it! All right, nothing's working. All right. Hold on. Okay, guys. There's a lot of lag this time, and so what I'm doing right now is I'm going to close out the stream. I'm going to post the code on GitHub, and I'm going to do a last. Hold on. Let me get that camera. Turn camera off. Turn camera on. Make sure it's there. Hold on. Hold on. Hold on. Come on, camera. All right, there we go. So, okay, I'm going to do a 5-minute Q&A now, okay? And then we're going to close out the session. And then next time, there's going to definitely be no lag. All right, so go ahead, ask 5-minute questions, Q&A. I'm going to get those. I'm going to get the code in GitHub later. Let's see. My parents are from India. I was born in Houston, Texas. We need a video on LSTM for audio. When? That's happening on Friday. Rob, I have video on LSTMs for audio happening. What graphics card do you use to train models? An NVIDIA Titan X would be ideal. What color scheme are you using in Sublime Text? It's the default one. What school do you study? I studied at Columbia. Heard about Amazon Go. I think it's a great idea. Well, which will be a great course for CV, computer vision? The self-driving car course on Udacity. Can you help me write a neural network to predict if a girl is into me? How would that work? You'd have to have a labeled data set of girls that are into you, and then some kind of set of features of why they are into you, or maybe unrelated. That's actually a great question. Maybe that could be an unsupervised problem. Girls that are into you versus not. Well, you have to have a set of girls that you know are into you for sure, and then a set of features. So you could learn those features, or you could just hard code those features. That would be better. Maybe the hair type, what they look like. What are the important features? What type of girl is into you? Maybe their personality, and then based on that, you could kind of predict what other girls would be into you. If you were able to extract those features. Facebook data would actually work for this. I'll reach you in San Francisco one day. Great. How should I start as a newbie in AI? Watch my videos. What company do you want to work for? No company, but I love OpenAI. I love them, and maybe Google. Age, sex, height. I'm 25. I'm male. I'm 6 feet. Video on string classification. I have one. I have several actually, but I'm gonna do more. Speak something for school. Yeah. And start downloading code for all of my videos and start running them locally on your machine whenever you have spare time, and try to get your professors to learn to do more machine learning stuff in all of your computer science classes. Machine learning can be applied to almost every field of computer science. No, not almost, every field of computer science. C++ or Python, and no video. How long do you sit on the PC and do research? I'm on my computer all day. Keras is a great thing, is a great library for starters, but I would prefer TF-Learn for starters. Okay. All right. So what type of music do you like? Mostly hip hop. Tupac, Kanye West, a lot of electro, and yeah. What's your favorite project in ML? I like, I like the synthetic gradients paper that DeepMind came out with. That was really like mind blowing to me. Okay, sex or Python? Oh man, that's a hard one. Sex is so like it just happens and then it's gone. So I would say Python if I had to pick. I know that. So anyway, I love terminal. I love CDing into directories and making directories. I just love being in a Unix shell. It's so awesome. And anyway, what is my motivation to continue learning machine learning? Machine learning is the solution to all problems. It is going to help us solve everything. It is the most important thing in the entire world. Okay. We have to solve intelligence, guys. Okay, where should I start learning neural networks in TensorFlow? Start with my videos, and then also TensorFlow has some great tutorials on their website. Do I have a girlfriend? No, I am newly single. Man, I get this question a lot. But I'm not actually looking for a girlfriend. So my girlfriend is Python. All right. So OpenAI is how I found you. All right. Anyway, thank you. Please do a live video on recurrent nets. Okay, that's it. Okay, cool. I will. I love you guys. Next time there is not going to be as much lag. I promise you. I want to do these live sessions every week. Okay, and I'm going to. All right. And thank you guys so much for showing up. Freestyle a song. I will freestyle. Okay, here I go. Here we go. What is the topic? Coffee. I love coffee. I do it back every day. I'm not me. I'm somebody else. My mind is so free. I see machine learning because I want to be something more than me. I want to go and flow and so high in the sky that my mind is so fried from doing this live. Okay, so that's my freestyle. I love you guys. I've got to go. For now, I've got to not have a laggy connection. So thanks for watching. Love you guys.